This is practice test 2, number 8, and we'll probably throw in number 9 too. Both 8 and 9 use the fundamental counting principle, which is from section 3.4. This is a biggie, and this will probably show up on the final as well. Good news is it's pretty easy. So when you're trying to count how many different options there are. If we were doing a tree diagram with this, I would have a branch for each color. So that'd be 1, 2, 3, 4, 5, 6, 7. There's 7 of those. I'd have 1, 2, 3, 4, 5, 6, 7. I'd have 7 color branches. And then off of each of those 7 branches, I'd have 2 types coming off. So if all 7 branches have 2 types, if I want to know how many tips there are, 1, 2, 3, 4, well, it's just the 7 branches times the 2 that they each have. So far we're at 7 times 2. And then off of each of those, I would have these 3 options. So doop, 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 doop. So it's just what we had times 3, because now there's 3 offshoots of each one of those. Which we don't even have to draw the tree diagram. We can just use this counting principle. Our first option has 7 possibilities. Our second one has 2. Our third one has 3. And our fourth one has 1, 2. We just multiply those numbers together, and there's 84. If I were to complete this tree diagram with all of these things branching off, at the very end there would be 84 little tiny branches. You could do that, but it would take up a lot of space and a lot of time. Let's look at number 9. So we've got a 3-digit code, 1, 2, 3. And we want to think, how many options are there for this first slot? Well, this keypad contains digits 1 through 5, so 5 different things that could be that first number. And then we want a code where the numbers can be repeated, so all 5 of them are possibilities each time. 5 times 5 times 5. This next one, where they cannot be repeated, there's 5 options for the first one, but for the second one of them gets used here, and so thus we only have 4 left we can use here, and then after we use that one, there's only 3 left we can use here. So we multiply all those up together, and we end up with 60 total.